Assalamualaikum. We are from Group 5. Today, we would like to present our slide, which is the title is Electric Vehicle Production Assembly Plant for BYD Auto. This is our team member, Nur Alisha Imaira, Nur Suhaila, Anas Farhan Shukri, Nur Hasrizal Muhammad, and last is Nur Hidayah. For table of content, we have introduction, company background, project prospect, competitor and unique work breakdown structure, estimation cost and TVOM, cash flow diagram, future word, reference and links, and value added.
The electric vehicle industry is rapidly expanding due to global demand for sustainable transportation. BYD Auto, a leading EV manufacturer, is planning to establish a local assembly plant to reduce costs and enhance regional market reach. This project applies engineering economy principle to evaluate investment feasibility, cost-benefit analysis, break-even and long-term profitability. It demonstrates how engineers make informed decisions by analyzing economic, technical, and operational factors in large-scale projects. Next, let me give a brief background about BYD, which stands for Build Your Dream. The company was founded in 1995 in Shenzhen, China. Its core focus is on electric vehicles, batteries, and renewable energy. Today, BYD has a strong global presence in over 70 countries, with multiple EV production plants worldwide. Some of their key innovations include the Blade battery, which is the fire-safe and a wide range of vehicles such as EVs, plug-in hybrids, electric bus, and trucks. As for milestone, BYD became the top global EV seller in 2023, and it's been backed by Warren Buffett since 2008. In Malaysia, BYD entered the market in 2020 through the partnership with Samdabi and currently offers models like the Atto 3 Dolphin and
Next, for project prospect, we have market growth, cost efficiency, government support, job creation, technological advancement, and sustainability goals. Next, for competitor and unique, we have main competitor, which is Tesla, NIO and Xpeng, and Volkswagen. For Tesla, we use premium EV ladder with strong software. For NIO and Xpeng, the Chinese startup with smart features like battery swap. And for Volkswagen, we use traditional automaker shifting to EV with strong presence in Europe. For BYD unique, we have vertical integration, mass production, and blade battery. For vertical integration, we produce its own batteries. For mass production, we use economies of scale to offer affordable EV. And blade battery, we use the innovation to save space spacing.
So next for the work breakdown structure for the BYD Auto company that we choose. So we start with the project initiation. So this includes overall planning, budgeting, and doing a site survey to make sure the land is ready for construction. Next is the plan design and construction, where we plan the facility layout, carry out structural work like building foundation and roofing, install utilities, and make sure everything follows the safety rules. Then we move on to the equipment procurement and installation. So here we buy the necessary machines, set up assembly lines, integrate the battery and motor sections, and test the equipment. So we move on to the workforce and training section. So here we focus on hiring skilled staff, training them in EV production, setting up safety procedures, and defining the roles and structure of the team. So after that, we have the quality control and testing. So these include setting up a quality system, testing vehicles like brakes and electrical, and making sure we meet all the compliance standards. So finally, we reach the commissioning and operation launch. We begin with trial production runs, fine-tune the system, and officially launch operation, and plan for continuous improvement through feedback. So each of these steps ensure we build a reliable, efficient, and future-ready EV production plant. So we move on to the estimation cost and TVOM, time value of money. So for our estimated project costs, we have overall of five category. And for the first one is the land and infrastructure. It will cost 50 million ringgit. Machinery and equipment for 80 million ringgit. Construction and setup 40 million ringgit. Skilled workforce training 10 million ringgit. And licensing and administration for 5 million ringgit. So the total estimate cost for our project is 185 million ringgit. So continue for the estimation cost and TBOM. So the time value of money application in our project, we use the net present value (NPV), which is evaluates the profitability over time by discounting future cash flow. For the internal rate of return (IRR), we use it to determine the expected annual return of the project. So the payback period is the time needed to recover the initial investment, typically 5 to 7 years for EV plants. So lastly is the future worth, which is we predict the future value of project return after 10 to 15 years.
Okay, this slide is about a cash flow diagram of BYD DEV assembly plant project. So, the red bar represent the negative cash outflow, with investment RM 185 million for starting construction or setup. So, the starting from year 3, the plant and production begin generating in positive annual cash inflow, which are 30 million as shown in green bar. So the cash inflow is consistent every year from year 3 until year 15. Okay, for year 0, the project require initial investment of RM 185 million for cover costs such as land, construction, human setup, and others activity. So this amount is recorded as a negative cash flow, which is outflow, uh, as it involves capital spending without any revenue or return at this stage. So in year 1 and year 2 is the cash flow is RM 0 because the project is still under development or construction. So year 1 is represent the construction phase, while year 2 involve setup and preparation. So during this year, the plant is not yet operation, so no income yet. And then year 3, the plant become fully operation and the production begin. So the project began to generate positive cash flow of 30 million. So this marked the start of regular income from operation. From year 4 onwards until year 15, the project continue a consistent annual net inflow of RM 30 million per year. So this is stable and ongoing return from the investment.
Next, for calculation, we use NPV formula where CT is a cash flow, R is discount rate, and T is for year. And for internal rate of return, we use method the iterative calculation using financial software. And for payback period, we use the calculation like at annual inflow starting from year 3 until the total reach 185 million.
Assalamualaikum, my name is Nur Alisha Imaira, and now I will explain about sustainability approach, which focus on three mains, which is environmental, economic, and social sustainability. First, for environmental sustainability, BYD focus on reducing carbon emission through electric vehicle operation. They also use renewable energy like solar and wind in their factory. Their blade battery design is eco-friendly and uses fewer raw materials. BYD implement a waste management system to recycle battery materials and production scrap. Plus, smart systems are used to improve water and energy efficiency. Next is economic sustainability. BYD aim to create around 2,000 direct jobs and 5,000 indirect jobs. Their supply chain supports local suppliers and they encourage export to increase revenue. With vertical integration, they reduce production costs. This project also attracts green investors by aligning with ESG goals. Lastly, on the social side, they provide skill development programs to train the local workforce in EV technologies. BYD engage with the community through educational outreach. Using EVs improve public health by reducing air pollution. BYD promote inclusive employment and follow strict safety and labor standards. Their second approach is the use of big data in their operation. First is smart manufacturing. BYD use Industry 4.0 technologies like automation and real-time data monitoring for smart manufacturing. Second is supply chain optimization. Big data helps BYD manage supply chains efficiently by predicting demand and tracking logistics. Third is quality control and product testing. Data also support quality control to ensure BYD products meet the highest standard. Fourth is customer behavior. They analyze customer behavior and market trends to improve product design and marketing strategies. And lastly is sustainability analytics. They monitor sustainability and energy usage to make our operation more eco-friendly.
Okay, we go to the Industry Revolution 4.0, which is the BYD EV project assembly plant at Pago Industry Park, embraced IR 4.0 technology to enhance productivity, reduce operation costs, and optimize quality in electrical vehicle man. Okay, next is the Industry Revolution can apply in technology, which is smart robotic, uh, which automate vehicle assembly line, and then IoT, which is Internet of Things that can monitor machine and system in real time, and then the next point is big data and AI that can analysis production efficiency and predict maintenance, and then cyber physical system CPS. So this technology can integrate digital system with physical process, and then last technology that can apply, which is cloud computing that enable remote monitoring and smart decision making. Okay, Industry Revolution 4.0 also can give a positive impact in engineering economy. For the first point is better return on investment, which is ROI. So this point can help earn back the money spent faster by working more efficiency. And then the next point is less waste and less downtime. With better planning and technology, the project reduce waste material and avoid delay in the work. And then the next point is support long-term sustainability, which is the project use eco-friendly method and save energy, which is good for environment and future. And the last point is create skill job and grow high technology in industry. So this point is open up more high tech job opportunity and support smart industry growth in Malaysia.
Next is environmental responsibility. Engineers should reduce harm to the environment by using green technology and safe waste methods. Next is continuous improvement. This means always learning, staying updated with the latest technology and improving skills. Last but not least, we have fairness and equity. Engineers must respect workers' rights, and make sure everyone is treated fairly. We also need to avoid choosing suppliers based on personal gain. These ethics help ensure engineers work responsibly and fairly. Now, let's look at the code's ethics. First is public safety and welfare. The engineer must always make sure their work is safe for everyone. For example, EV part like batteries must follow safety rules. Second is accountability and transparency. Engineers should keep clear records of all money decisions. They must also be ready to explain their choice if asked. Last is honesty and integrity. They must give true information about cost and project result. Don't lie or mislead people like investor or the public. This value help engineers do their job the right way.
The slide show the reference that we use to do our project. That's all from us. Thank you.